Hey guys, this is Rob with the next video in the Electrical REVIT project series. We left off on the last video as I open our project. Tutorial, there we go. Create new local and override existing. Same as before. We left off having put in some electrical fixtures or devices like receptacles and quad receptacles and equipment connections and motor connections. So the next natural workflow for SD or DD set would be to try to show some branch panels and even switchboards if you have those, to get an idea of what kind of space requirements you may need for electrical rooms and on different floors, etc. It's pretty much a guess at this point based on previous experience, so it's not going to be exact. There's been typically no sizing by now unless you've done some kind of a square foot sizing for your building or for your floor. But this will at least show how to place these items in your project in a DD level. So let's go to our first floor power plan that we are getting used to seeing. And one thing I wanted to note as a remnant from the previous video is our load centers, which we placed on the second floor. Load center connections are what they actually are. And we put those on the second floor, as you recall, right here. And we really should tag these. Get a leader. Tag that. And we'd put in let's look at the type parameters. We had put in a type mark called unit panel. Even though it's a load center style of panel board, it's not a panel board style. I like to call it a unit panel. The architects and owners seem to understand panel. You say load center, they get a bit confused. So I just call it a unit panel. And we can just tag these as such. And you would do that for all of the apartment units so that they can be circuited later. Anyway, what happened on the first floor is I see those. These load centers are showing up down below. Now, again, I mentioned before when we dealt with that view range, this is pretty common for things to show through where you don't want them to. So is it a view range problem, or is it a device placement problem? In this case, since they're the only thing showing through, I think that we're going to check the device fixture placement issues. Let's click on this and see what elevation it's put at. Over here on the right, it's on level 2, which it's supposed to be, but it's only 1'6" from level. Now, a lot of times these devices are to the center of the device or fixture. So a load center, 1'6", well, it's probably not high enough. So what we'll do is we already have a section here that we used to see our generator room. We can probably use this again to see this load center. So let's double click the head of the section and dig down here to levels 1 and 2. And this is the electrical discipline view. So it's an X-ray vision, but it'll give us an idea what's going on. Right there is our load center. And as you can see, it's 1'6" to the center, which puts the bottom below level 2, and that is why it is showing up. So we need to raise this. And what this also tells me is that we probably need to change our template and get these load center connections higher by default. So that's something that becomes apparent as you use some of these families. For now, let's raise it up to, let's see. Let's go 5 feet to the center. Oh, I still have tag on. So let's go 5 feet to the center. Apply that. There. And raised up to something more appropriate. You know, if you need exact height for some kind of an interior elevation, we don't typically do those. But if for some reason you need to detail out a wall, then you can play around with that height and get it to the right height. I may have shown this before. I'll do it again. You can use up the quick access bar. You can use an align dimension anywhere you want to see where things are, and you can use the dimension to actually move things. I think I showed that in the receptacle heights. So again, what we can do here, and 6'8" is actually pretty good, but let's say we're going to make that 6'6", and that'll pop that down to where we want it. The top is 6'6". So again, dimensions are handy for actually placing things. And we'll want to do the same to the other one. So with this one, well, let's see, what did we end up with at that one? That one at 4'10". Yeah, 5 foot's close enough for our purposes. So we'll go 5 foot with this. Now, any future ones we do should be the same. If we do right click, create similar, any future load centers that we create from this one should end up at the 5 foot because we created similar to the other one. So once you've got that adjusted and use create similar, now you're not relying on the default that you got when you dragged it from the project browser. Now you're mimicking what you've already done. I'll just tag this one since we've put it in. Okay, that's enough of those. I just wanted to deal with that issue. Every now and then something like that comes up that you have to interrupt your workflow and fix. So we fixed that. Now we can move on to placing what REVIT calls electrical equipment. So we will close down the electrical fixtures category and go to the electrical equipment category. Here are all the families we have, and these all have MFIA, so these are all custom families that we've modified for our purposes from the generic out-of-the-box REVIT version. Not a lot of modifications, but a few here and there to help us. And you can see we have dry type transformers, all different sizes. We've got some pad mount transformers of different sizes. We've got a bunch of panel boards. Now, we have them broken into recessed or surface, main circuit breaker or main lug only, and by voltage. Furthermore, within each of these families are types for the, the capacity, the amperage of these. So there's a lot of different panel boards that can be put in. Now, when we're doing a DD level, we typically don't know what size panel boards we need. So we just have to pick one. It can easily be changed later. That's a nice thing about REVIT. In fact, I heard the story behind the name REVIT came from revise it, because it's made to easily be revised once you've created a model. The workflow nowadays is guess and go. Guess on the size, later revise it to make it right. So that's what we'll do. We've decided to do this building in 208. So we're going to use a 208 panel board, and let's put one for now in our electrical room, a branch panel, and we'll go with a 208 main lug only, and let's put a surface mount board. I'm going to guess right now, let's go with a 225 amp. So grab that and drag it. Now, it won't let you place it in the middle of the room because the panel board happens to be a wall hosted like receptacle. Get close to a wall and it'll snap there. Close to a wall and it'll snap. So let's put it right here for now. We'll leave the rest of this for switchboard. So place that there. And something I didn't bring up during receptacle placement is if you decide you want this panel on this wall instead of this wall, it won't let me do it. It stays on this wall. I can slide it along the wall, but I can't remove it from the wall because it's attached to it. So how do I move a panel from one wall to another? Well, I could delete it and then reinstall it here. But sometimes you have things already, in your panel, like we're going to name it and do things like that. So we don't want to have to recreate that. So let's just move it. The way you do that with a hosted device is we have to, up top here, under the Modify Electrical Equipment, there's a Pick New. Pick New what? Well, it ends up being a Pick New Work Plane. So, a plane is a flat surface, so we get to pick a new flat surface that this will be hosted to. Moves the selected work plane based element to a different host. So this wall here is a different host, a different wall than that wall. So we're going to say pick new, and we get choices. We can either put it on a vertical face, like a wall, which is what we have done, or any other face. Well, that could be a ceiling or a floor. It could be a wall, but it could be another face. And then also it could be on some separate work plane that is created that's not a ceiling wall or floor. Sometimes you don't have a ceiling or floor and you have to create this artificial work plane to attach things to. Luckily we don't do that often, but probably a future video will have to deal with that at some point. But for now, we're going to keep it on a vertical face, and now it releases it from the wall it was hosted to and lets us move it to some other wall, any other vertical surface. So we could put it here. So let's go ahead, and it's behaving crazy. As you can see, it gets sensitive there. All right, so there we go. We got it close to that wall. Click. Now it's attached to that wall. All right, let's take a look at a panel board. What's in a panel board? Remember, these here are our instance parameters, which means just for this one panel that we've installed. We've got elevation. Now this elevation happens to be to the top. And that gets confusing because some devices or equipment are to the top, some are to the center, some are to the bottom. So it depends on how that family was created. In this case, these panels are set up for 7 feet to the top. I think the generic out of the box REVIT is to the center, which was more like that load center we saw. But this is to the top, and you can drop a camera or a section in here to take a look at that. And I think I'll do that right now. It's helpful to see what things look like in the 3D view and section view. And it just shows the ease that we can create a section. Put a section, here we are, there's our panel. If we drop some dimensions in here from the floor up to the top, we can see, yes, we're at 7 feet. And it kind of looks like a panel. Something else I'll bring up is, the panel, pretty thick lines. Some of these things are set up by default to be pretty thick. If you're having trouble seeing things, you can use a button, another button up here at the quick access toolbar. Up here, there's a little button here called Thin Lines. Displays all lines on the screen as a single width regardless of the zoom level. Click on that and everything becomes a tiny thin little line. And sometimes it's easier to discern details this way. I'll turn that back off. So that's our panel board in section. Oh, wrong floor. Let's see what it looks like in 3D. Remember up here the little house? Drop down to camera. And we'll place a camera in this other corner of the room right now. And we'll shoot it beyond the walls to look at that panel board. We want to change it from electrical discipline, which is X-ray vision, down to a coordination. And that gives us hidden lines. Let's change that to shaded. Okay. Use our F8 to get our looking around icon. So that's a nice tall room. And there's our panel board against the wall. So that's what it looks like. It's, again, if you need to do some kind of a section or 3D view, even just for design purposes, it actually looks like a panel board. Okay, back to our first floor power. Let's see what is in this panel board. Again, we were looking at instance variables. We saw the height. We don't need it offset from the wall. Again, you can offset things from the wall if you need to show multiple. If we had two panels stacked vertically, well, in plan view, that it would just look like this. We may want to add a offset from the host of, let's go a foot, so that we could have this panel offset from the wall. Now it's still attached to the wall in the model, but it would just show this way so we could show another panel here if we need to stack. But we will just go ahead and put this back to 0. But that offset is from the host, which is the wall. Now we have a bunch of stuff here that automatically gets calculated, all the electrical loads, like kind of like an Excel spreadsheet panel schedule. This all happens behind the scenes. Don't need to worry about that. Here's some more stuff we don't need to worry about. So there's only a few things we worry about in this instance view. We don't have different phases. We're not going to worry about that right now. Mounting is surface. That's hard-coded into this type called surface, so we can't change that. We don't worry about the enclosure. Panel name, this is what we care about. Let's type in a descriptive panel name for this. In this project, our labeling scheme is by floor. This is first floor, so it gets called 1 and then just panel A, the first panel in the series. It automatically tells me that it's in electrical 133. It knows that. It's grayed out. Now, down here, maximum number of single pole breakers. Well, this is by default, it's set up as a 42. This can be changed. You can put it up to 84. You can put it wherever you need to. I'm going to leave it at 42 for now. The mains are set up as 225 amp main. Subfeed lugs happen to be checked. We'll deal with that later. And a lot of this we're going to deal with later when we circuit things up. But I'm just giving you an overview right now. Now, this main circuit breaker rating 1, well, this doesn't make sense. But there's no main circuit breaker in this panel because we've gone with a main lug only. However, this parameter still shows up. So it can be anything right now. It's just a placeholder. And then the distribution system, we want to make sure it's set up for 208. It should be. I've had a few older templates that it wasn't set right. So just make a note that that's correct. We can change that if we need to. In this case, it won't let us change it. And it's just a 4-wire, 3-phase. It's telling us it's 208. And the numbering option, the default, we can set up later when we do circuiting. We can set up how the circuiting happens, whether it happens in numerical order, like circuit 1, then circuit 2 and 3. It'll automatically pick the next circuit, or we can have it pick 1, 3, 5, 7, which is how we would typically circuit down one side of a panel board. Anyway, that's what that's talking about. We can deal with that later. So much of the stuff happens later when we circuit it, but that's what's in the all the instance parameters. Now, what's in the type? There's not much in the type. Load classification, well, it just says other because it's not a load, so it really doesn't matter. It just distributes to other loads. Here's all the dimensions, and you can see that it's got built-in different heights for different circuit quantities. And then, there's not much here for this type. And if you look at other types, they may change the dimensions, but that's about it. Now, something to note is as we put multiple panels in, we don't need to create separate types for each panel, because the panel name and circuit quantity and things like that are over here in the instance. So this is where we will put panel names and such. So panels, we can just put another panel. Let's create a similar. Put another one over here. Now we click on this and it has a blank panel name. This is where we put the panel name in. We don't need separate types for each panel. And here we're going to call this 1B. We've got 2 panels. Apply. 2 panels on this floor. Now let's tag them. You can use a leader or not. On panels, sometimes I will just leave the leader off and just get this close. And it underlines it automatically. Our panel tag is customized to underline the panel name to help it visually stand out. And I'm going to move the room name. In fact, like I did here, I'm going to move the room name outside. If you recall in previous videos, we can attach a leader line to this. So click on the room tag. I'm in the room tag. And on the left over here, let's click on leader. And before I get out of this, let's move it out. And once it's out here, then I can move the leader. Escape out. There we go. It gives me more room to show my stuff. So that's how panels work. Now I can put panels, on the second floor, wherever I need them. But that's how we do panels. If I need to change this panel, let's say we decide that, no, this becomes some kind of a finished room and we need these panels recessed, you can click on that panel, and up here I can choose a different family and type altogether. So 208 main lug only, here's my 208 main lug only recessed. I can just change it right now to that, and you will see that the panel changes graphically to a recessed look. All right, so that's how you can change things. I can also change, let's change it back to surface, 208 main lug only surface. I can also change to a different amp. However, let's go 400 amp. This is 400 amp. However, look, this doesn't change because this stuff is all an instance. So it's kind of one thing that's kind of annoying with panels is the amp rating is not part of the type parameter. The size is. So if you get certain panels, maybe a 600 amp panel might be larger, like an I-line panel, it'll be bigger. But the actual amp value is here. So we have to pay attention to that. Again, that'll mean more when we start circuiting, so let's just put it back to 225. Okay, what's another piece we can put in? Let's put in a switchboard. Down here at the bottom, we've got switchboards, 208 or 480. So we have different sizes. Let's say we did some square foot calcs in this building. We decide we're going to need a 1600 amp service. It can be changed again later. Drag this over, and it's just a box. Now you can see my crosshair is at the top center of this box. That ends up being the insertion point. Remember the space bar will rotate things. If I hit space bar, it rotates around that center point. So I'm going to mount this to this wall. And let's just put it right here. Okay. Now I saw a 480 jump out. So we need to go through and check this out. What do we have? Some of these things come in. Yeah, some of these things come in not right. It could be a template issue, or it just could be it's built into REVIT, something weird. So what we need to do here, let's go check the type. On switchboards, the voltage is part of the type. So this here, we can just type in 208. Apply, okay. Now that to me means that's something in our template. So I need to go back and fix that template. But if you run across something like that, let me know and we'll get it fixed. So now I typed 208 there. Now I should have a 208 option in my distribution system. And there it is, 122.08. So we fixed that. Okay. Now the rest of the stuff is mainly when we circuit, but maybe we want to change the size, and a switchboard happens to be an instance variable, not a type. Again, with use, you'll get familiar with what's what. So the width, length, height. Width, I think, actually is depth, and the length is this way. So let's make this a 9-foot board. And I was still in the tag, so we need to do that again. 9 foot. And apply. There it is. And I can move that around. And click on it again. Now we need to give this panel a name. Let's call it MDB, a main distribution board. Apply. Now we can tag it. Escape out. There we go. Now, this is perfectly fine for an SD or DD level. Now, when we get to 480 volt systems, we'll have transformers. We'll have different voltage of boards. And you can use all of these types to do that. For example, look at the dry type transformer. Let's put a 75 kVA in. Again, it kind of looks like a switchboard because it's a box. Let's say that's going to be down here, a bit from the wall. There's our transformer, and it's right at the level. If we need to put it up on the wall, we can raise it to 6 feet, 7 feet above the floor. And we give it a name. It's called panel name, but it's a name of a piece of equipment. And let's call this Transformer A, TA. And it's connected, primary of it's connected to 480. When we get to circuiting, we'll look at all those things too. But I want to take a look back at our 3D view of this room. Now it's getting full. So if we hit F8, we can do a quick little, remember, slowly move that cursor to get the walk to work. If you move it much past here, it will just zoom off the property. Let's go over to this panel. Now change to look and hold that down. Now let's take a look. There's our switchboard. There's our transformer. It's just a box. But some of these things, they kind of represent what you may see. It gives an idea. All right, so that's the basics of putting panel boards and switchboards and transformers. We don't need this in this project into a space. The pad mount ends up being 500 kVA, ends up having, I don't have a site plan, but if I had a site plan, I could put this on, ends up having the typical utility clearance marks around it. So we can make sure that we're keeping it clear for the utility. And that's useful for example, a site plan. So that's the basics of putting panel boards and switchboards. If you have a meter center, we have some meter stacks, and these can all be circuited later. Let's say, for example, one more thing, a surface electrical cabinet. This is just a generic electrical cabinet. Say, for example, if we had a smaller service and we had a CT can outside, you could drag this over and turn this into a CT can. And it's got dimensions, and this one actually you can play with dimensions with these arrows. You can't see exactly what they are, so if you want them specific, you can either draw dimension lines on it or you can do it up here. So let's say the box height is 4 feet and the width is 3 feet for a CT can, and depth would be 1 foot. Apply. So now we have a CT can, and this will, if I put a camera and look at it, this will end up looking like, go to coordination view, ends up being invisible. What did I do? Let's see. Let's look down. It's down there. So it ends up, looking like a 3D representation of a box. Again, we don't do a lot of 3D, imagery, but it's helpful to make sure our design seems right. So that's just a standard electrical cabinet that you can use. You can use it for a generator. You can use it for a number of different things. So that's it for this video. We will continue on in the next one. I think the next appropriate thing for a DD level is to start on a lighting plan. So that's coming up next. And let's sync and close and call this done.